Ladies and gentlemen, on January 25th, Qualys security researcher came up with a blog which talks about a critical privilege escalation vulnerability that affects almost all the Linux distributions available. And the vulnerability is called Pwnkit. They colloquially calling it as Pwnkit, and it affects the Linux policy package called Pwnkit. So in this video, I'm gonna explain what is the Pwnkit vulnerability and how it can be exploited and what are all the remediation steps to be taken. Without wasting a time, let's get in. Now we are in Wallis blog page. Actually, this is the blog that was initially released by the security researcher called Bharat Jogi. Kudos to him. And this particular blog talks about that vulnerability in detail. And there are more technical stuffs when you scroll through, but as a beginner or an intermediate researcher, it might be quite difficult for you to understand. So as usual, I'm going to refer TryHackMe room, and people explained Pwnkit vulnerability in simple manner in this room. So I'm going to use this room as a resource to explain this. So here we are in the Pwnkit room, and the CVE ID is 2021-4034. An interactive lab for exploiting and remediating Pwnkit in Pwnkit package. Pwnkit is the affected package, and the package stands for policy kit. So which is present in almost all the Linux distribution by default. This is what makes this particular vulnerability more ubiquitous and more devastating. So we already began the machine. Let's read through this exercise. The introduction, that is a CVEID, also known as Pwnkit, and it's terrifying local privilege escalation flaw, which means you can elevate the privilege in the local system only. In order to exploit this vulnerability, you must have a minimum privilege. So that is the prerequisite, and this is only one good factor in this vulnerability, and located in Pwnkit package, installed by default in almost all Linux distributions, as we already said. And in other words, it affects virtually every mainstream Linux system on the planet. So almost all Linux systems are infected, are vulnerable. So this room will provide, so this room we are going to talk about that vulnerability only. The task 2 will talk about the background of this vulnerability, and task 3, it's a practical task where we are going to use the TryHackMe's machine, which is vulnerable to Pwnkit, and exploit that vulnerability. And the third one, the third task, remediation, where they gave the remediation step. And finally the conclusion. So let's begin. Let's go to the background. So in the background, let's get to know more about this Pwnkit. It is also known as Pwnkit, discovered by Qualys researchers on Jan 2022. Technical security advisory of this vulnerability can be found here. So they also gave the link. I'll be adding it in the description. The vulnerability has existed in every version of Policy Toolkit. So the Pwnkit stands for Policy Toolkit, and since 2009. Actually, the Pwnkit released in 2009 for the very first time. Since then, this vulnerability was there, but we managed to detect that vulnerability in recent times only, and allows any unprivileged attacker to easily obtain full administrative access on any Linux machine with Pwnkit package installed. So this is the very notorious thing, and unfortunately, Pwnkit installed in most of the Linux distributions and making vulnerability extremely widespread, as we discussed. And the ease of exploitation, the exploitation of this vulnerability is very easy, and it is ubiquitous. So it makes this vulnerability absolutely dangerous, and it is not exploitable remotely, and making it as a local privilege escalation. So let's see what is Pwnkit. Before we look at the vulnerability directly, it helps to understand what Pwnkit actually is. Pwnkit is part of Linux authorization system. In effect, when you try to perform any action which requires high level of privileges, for example, if you are using a Linux system with a low privilege, if you decide to execute any command which is usually run with high privilege root privilege, in that case, when you are executing that command, the Pwnkit will check whether you are having the required adequate privilege or not. So that is the role of this Pwnkit package. And Pwnkit can be used to determine whether you have requisite permission or not. That's what I said before, now. And it is integrated with system daemon, is much more configurable than traditional sudo system. In other words, if you want to keep simple in your mind, then you can keep like Pwnkit is similar to sudo. Sudo is a binary, a package, a feature we are using to execute the high privilege command. So super users do. And Pwnkit is almost similar to Pwnkit. Sorry, Pwnkit is almost similar to sudo. Pardon me. Indeed, it is sometimes referred to as the pseudo of system daemon, and providing granular system with to assign permission to user. So they also gave one simple explanation here. So what they are telling is, when interacting with Pwnkit, we can use pkexec utility. Since we have the Pwnkit utility or the package, we need to interact it with the package, right? And for that, there is a binary that is called pkexec. Actually, this binary is present in every Linux system. Actually, this particular binary is vulnerable to Pwnkit. And an example of the utility they gave, they are going to execute one command, user add, to add the user in the Linux system through the command pkexec in GUI session, and it results the password request prompt. So this is the simple command they added. Now let me explain the command in a simple manner. Now I am as PerumalJegan, the user is already added in the system. I'm gonna add the same user in the system by using the pkexec utility. So let me try pkexec user add PerumalJegan. When I click, I'm getting the prompt. It is asking me to enter the password of mine. So when I enter my password, it says the username already exists, which means as a low privilege user, I try to create, I try to add a user with pkexec. It asked me the password prompt, and once I entered the password, it tried to create a new user. So this is the flaw. Actually, this is the not a flaw. This is the characteristics of this pkexec utility. Not a flaw. This is the pkexec utility's character, and they also mention the same here. So in a CLI session, if you try, it will ask like this for a password. So that's what they gave. And so let's see a little bit in depth and the vulnerability. As mentioned previously, Pwnkit vulnerability exists in pkexec utility, the primary front end to the Pwnkit system, an interaction. And we won't go too much in detail here in the interest of readability. However, you are encouraged to read through the Quality Security Advisory. They gave the Quality Security Advisory. When I was reading through that advisory, I was not able to understand few things. So I simply chose this particular room to explain this vulnerability. Okay, the short version of this, the version of pkexec released prior to the patch, don't handle the command line arguments safely. And this is what leading this particular package to its that vulnerability. Actually, it failed to handle the command line arguments properly, which leads to out of bounds write vulnerability, allowing an attacker to manipulate the environment which PsExec runs. So this is all we really need to know. You can simply keep it in mind like pkexec utility, the vulnerable utility fails to handle the command line arguments properly. So that is why this vulnerability arised. So you can keep simply as simple as that. More specifically, if you want, so let me explain a few more lines here. pkexec attempts to parse any command line argument that we pass it using for loop. Actually, the pkexec utility parses the every arguments that we give in the command line using the for loop, and the for loop is given here. So starting at the index of 1 to offset the name of the program, obtain the first real argument. So let me explain that here. Uh, for example, let's take a simple command creating directory, make directory. So it's a command, and I'm gonna create 2 or 3 directories at a time, like test1, test2, test3. So now you can see this command. We are using a command make dir directory, and we are passing 3 arguments here: test1, test2, test3. So instead of make dir, if we use the pkexec, it simply index these arguments as 1, 2, 3. Test 1, test 2, test 3 I gave, right? So it is indexing as, it is indexing as test 1 as 1, test 2 as 2, test 3 as 3. And this particular command is argument of index 0. And this will be, this will not be considered, and it will take from this argument only, since this is a base command. So this is how the pkexec index its arguments, and it ignores the offsets the 0, and it considers from 1. And that's what they gave in this for loop. And the n is 1, it begins from 1. And when the argument, the number of arguments they gave here, the total number of arguments, for example, take this case as well. We are giving 3 arguments here, and here let's take the number of arguments is 3, and n is equal to 1, because the argument is always starting from 1, and the 3 is obviously greater than 1. The condition satisfies, and it does the certain stuff, it executes the function. But what if this n value is less than 1? Let's take it as 0. What will happen? And I think that is where this vulnerability arises. Let me explain it proper way. And I explain, they're explaining that only in example. If we entered pkexec bash, the first argument, then pkexec is the name of the program, it would be argument 0, and the actual command line argument starts at index 1. So you need to keep this in mind. And the name of the program is irrelevant to argument parsing, so the indexing is simply offset to ignore it. So the name of the program will be ignored. And what happens then if I don't provide any arguments, the index is set to permanently 1. If I didn't provide any argument, then the argument index is simply set to 1, as the n is 1 by default. And the following pseudocode may help you to visualize this. All right. And if the number of arguments is 0, then n is never less than the number of argument. Obviously, this condition is gonna fail since the number of argument is 0. And as such, n stays equal to 1, and the loop bypassed completely. This loop will be bypassed. This becomes a problem later when pkexec attempts to write the value of argument at the index n. So this is where the problem arises. As there are no command line argument, there is no argument at index of n. Yes, and instead of the program overwrites the next thing in memory. Instead, the program overwrites the next thing in memory. And since there is no argument is given, the program try to overwrites the next thing in memory. That's what they are saying, which just so happens to be the first value in the list of environment variables. Oh, actually, the program will try to manipulate the first parameter in the environment variable. And when the program is called using C function called execve. So execve is a function. Let's see what is execve. The execve function replaces the current process image with new process image specified by the path. So it is just replacing, doing some replacement function, and the new image constructed from regular executable file called new process image file. No return is made because the calling process image is replaced by the new process image. So this is a brief explanation to this function. And in other words, bypassing pkexec a null list with a null list arguments, we can force it out to override the environment variables. So you can simply keep like this. By passing pkexec a null list of argument, no argument, we can force it that function. We can force that program to write the override the environment variable, and that's it. And for the context, certain dangerous environment variables are removed by operating system when you attempt to run the program that has the SUID bit. Actually, this particular pkexec binary is set with SUID bit. SUID bit is separate topic for the separate video, and they are trying to say like certain dangerous environment variables are removed by operating system when you attempt to run that program, the vulnerable program. So it will do some manipulation in the environment variable. And this is to prevent attackers from being able to hijack the program as it runs with administrative permissions. Using the out of bound right, we are able to reintroduce our choice of these dangerous environment variables by clicking pkexec adding for it. So this is the variety of different way to abuse it, all leading to code execution as a root user. Now let's try to answer the question: is Pwnkit exploitable remotely? No, it's a local privilege escalation flaw, and that's the answer. In which Pwnkit utility does the Pwnkit vulnerability reside? And as I said, the package is called pkexec, and that will be the answer. Now we are in the exploitation part. The exploitation part is very, very simple, very easy part. They also give their machine. We are just going to log in their machine and going to compile that exploit, and we are going to execute that compile the exploit. Then we will be getting the root privilege, and we need to fetch the flag from the root directory. So that is our objective here. So the version that we will be using, the written in C, the exploit is written in C and was released soon after the quality security advisories was made public. The repository can be found here. They also gave the POC path, which is the POC actually released uh, to the public. So they also gave that path. I'll try to give that path in the description. This variation of the exploit makes use of dangerous gcon underscore path variable to include a malicious share file object that calls binsh shell. I mean bin shell with root permissions. Now let me open this exploit. So now you are viewing the exploit. What this particular code doing is it simply uses this gconf underscore path environment variable in Linux to include the malicious shared object file, which brings the shell with root privilege. And here you can see the main function. So that is the overall objective of this exploit. And now let's connect this machine and let's see how easy to exploit this vulnerability. I'm copying this. I can simply SSH the machine, TryHackMe at the IP, and the password is now we logged into the machine. I'm having a directory called Pwnkit. I am TryHackMe. I'm not root as of now. So let's see. Let me move on to the Pwnkit directory. I'm clearing the screen. I'm having the exploit file ready here. So let me cat this out. Now I can see the exploit already present here. Actually, this machine is vulnerable to Pwnkit. Now let me try to compile this vulnerability. When I'm compiling that C program, it will change the user readable format to machine readable format. And CVE, I'm simply using GCC compiler, GNU compiler, and -o output. I'm storing that exploit file as exploit. Now it got compiled. You can see the new file got created. When I see what sort of file is, it gives me ELF, executable linkable format, 64-bit, dynamically linked file, and used to file, I mean compiled by GNU compiler and not stripped. So this is about the executable file. Now all I need to do is to exploit this. So to execute that exploit, that's it. I'm going to trigger that exploit. Now you can see the prompt changed. Now I am giving who am I? I am the root now. And my present working directory is the low privilege users home directory, and I need to switch the directory, switching to root. Now I can read out the flag document. I managed to got the flag. So now we just spent few seconds to exploit this vulnerability. So this is what the critical thing about this. So try to patch it as soon as possible. Now I copied this. Let me put it in the answer section. They gave a task, read through the POC, the Quality Security Advisory, and I'm adding the flag here. And the next question is, you can write your own exploit. Since it is very easy to write your exploit, we know the objective, what needs to be done. So you can try to write your own exploit. And I think this might be the video for, this might be the concept for the next video or the upcoming video. All right. So this is what about the exploitation part. Let's move on to the remediation. Now that we have seen the devastating impact of that vulnerability, fortunately, developers tend to be fairly fast when it comes to developing patches to the critical vulnerability. Now, I I used the TryHackMe's machine to showcase this vulnerability. What if I use my current machine that I'm running? I'm currently using Ubuntu machine. I'm running on Ubuntu. What if I use my, what if I test this exploit in my current machine? Actually, I'm having the exploit code ready. All I need is to compile the exploit and -o. I'm putting it as exploit. Exploit is created. As I said, I'm running Ubuntu machine. Now let me try to exploit this. It is not working. The exploit is no longer working because the canonical already patched this vulnerability. They were very fast. Before Qualys released their advisory, they managed to patch that vulnerability. And as prime example of the time of rating, that's what they are saying. Canonical have already released, patched the vulnerability. And if you want, if you are using Ubuntu machine and this vulnerability is not yet patched, feel free to use this command to upgrade your package and patch it. So if you are using some other distribution and the patch is not yet available, you can use this command to remove the SUID flag from the package from the binary pkexec. So let me showcase this first of all, where it is located. In real machine, if you see, it will be located in user binary pkexec. So user USR binary, this is the path where all binaries will be located. For example, if I am using uh, a command called cat, let's take a command called cat. So if I need to check its path, if I give which cat, it will show where the binary is located. And this is the path contains most of the critical binaries in Linux system. So if I see ls-la, I can see it is flagged with yes. Yes is nothing but SUID flag. So this is what a workaround. So if the patch is not yet released, you need to remove this yes from here. To remove that, they gave this command, change chmod 0755. That is the code to remove the yes flag to that particular package. Then it will be mitigated temporarily. But the permanent solution would be patching the machine. So this is the patched scenario. I used the same thing in my Ubuntu machine. I was not able to exploit that. So this is how it looks like when it got patched. Remediation task. So these are all the simple advisory. And the next part is conclusion. Conclusion is just an overview of what we already seen. So nothing here. And they also having another room. Probably I'll be making this exercise in future videos. So we successfully learned what is Pwnkit. And this is all I had to share. Actually, it is local privilege escalation vulnerability, so it can't be exploited in remote. So that is a good factor about this vulnerability. However, it is still notorious because it can be any unprivileged user can exploit this vulnerability and become root by doing some simple stuffs. So try to follow up your security vendor and get it patched as soon as possible. And I'll be giving the remediation step, the command that I mentioned while explaining, uh, the command to remove the SUID binary from the, SUID flag from the binary. So I'll be putting it in the description so you can refer that. I hope you really enjoyed this. If you really did, consider hitting the like button, and you can consider subscribing my channel. If you have any opinion, put it in the comment section. I'll be reading and replying to your comments. And you can share this video among your friends. So this is it. I hope you really enjoyed this. I'll catch you next time with another exciting video. Until then, signing off. Love you guys.